history of the atom begins in ancient Greece, with a man by the name of Democritus. He lived from 460 BC to 370 BC. Democritus was the first one to even come up with an idea even vaguely similar to the idea of an atom. He said that matter can only be cut a set number of times, and after that it becomes too small to cut. This is why we have the word atom, which comes from a Greek word meaning uncuttable or indivisible. Nothing was done for the next 2 millennia regarding the idea of an atom until we get to an Englishman named John Dalton. He lived from 1766 AD to 1844 AD. His atomic theory stated that all matter is atoms, and all atoms are indestructible and cannot be split. Number 2, all atoms in a certain element are the same and have the same mass and chemical properties. Number 3, compounds happen when 2 or more different types of atoms combine. And number 4, chemical reactions are only rearrangements of atoms. And John Dalton's theory stands true today, except for 2 things. 1, not all atoms in an element have the same mass, there are isotopes. And 2, atoms can be split by the way of nuclear reactions. The next atomic discovery would come from a man by the name of William Crookes, who was a British chemist and physicist, born in 1832 and died in 1919. He was studying how hot metals react in a very low pressures, and thus he made the cathode ray tube, which at low pressures and a hot piece of metal inside would cause a little bit of gas inside the tube to glow. Now, he didn't quite know what this was. He only knew 2 things really, that it was some form of radiation, and that it was whatever it was negatively charged as it was attracted to the positive pole of a magnet. The scientist who did figure out what these particles were was J.J. Thomson. He was the first one to determine the existence of electrons. J.J. Thomson discovered electrons by building his own cathode ray tube and then measuring the heat generation of the particles and the magnetic deflection of the particles and doing some uber mathematics with that, and he determined that whatever these particles were, they were much smaller than a hydrogen atom, which chemists at the time thought that would be the smallest building block of matter, and he also determined that they were negatively charged. He also determined that no matter where electrons come from, they will have the same mass and they will have the same charge. This gives rise to the charge-mass ratio, which is 1.759 by the 10th to the 11th power coulombs per kilogram. Coulomb being a measurement of electricity and kilogram being a measurement of mass. Now, if he would have stopped there, he would have been completely right, and our scientists would look back at him and say, "Good job, you did nothing but good in your life." But no, he had to try to further science some more, so he decided to come up with a model for the atom called the plum pudding model, which now we know is incorrect. But anyway, the plum pudding model basically says that an atom is made up of electrons surrounded by some form of positive charge. Didn't know what the positive charge was, just positively charged stuff around the electrons. The scientist to prove him wrong was Ernest Rutherford, who lived from 1871 to 1937, and was born in New Zealand. He proved J.J. Thomson wrong by performing the gold foil experiment. The idea was that if you fire alpha radiation, which is just a type of radiation, at gold foil, and Thomson's theory is right, most of the radiation should just pass on through. However, if most of the mass is concentrated in a central location, then some of it should bounce off, and we should be able to observe that. And guess what Rutherford observed? He observed that some of the radiation was bouncing off, and therefore he knew that Thomson's model was wrong, and they lived around the same time, so he probably went up to Thomson one day and he was like, "Yeah, you were wrong, come on, give it up," and gloated about it to Thomson for the rest of his life. Ernest would probably call Thomson's house late at night and say, "Hey, did you order some plum pudding?" And, Thomson would say no, and Rutherford would be like, "Well, we didn't either, why'd you give us some?" But anyway, through this process, Ernest Rutherford discovered the proton. But now, there's another scientist who discovered the neutron that was not Rutherford. His name was James Chadwick. He was an English physicist. God, there's a lot of English people on here. There's like one American and then nothing else. But I guess the British are good at that stuff. But anyway, he lived from 1891 to 1974. He discovered that neutrons were a thing by firing neutrons at some form of wax, and it would knock out protons. And he was able to observe that somehow and figured out, hey, there are neutrons too. But now let's go back to the electron for a second, because I forgot to talk about something. Anyway, his name is Robert Millikan, and he was the one who discovered the charge of the electron with the oil drop experiment. He basically took an oil drop and suspended it between two electric plates, and then he would amp up the charge until it kind of was floating a little bit, I suppose you might say. And by that, he was able to calculate the exact charge of the atom, comparing it to the gravitational forces and stuff. And he was a very mathematical person, as were all these people. But math. He determined the charge of an electron to be negative 1.602 times 10 to the negative 19th coulombs. One more thing before you go. We need to again talk about the proton and the neutron. The proton and the neutron are the nucleus of the atom. The nucleus has most of the mass of the atom and is where the electrons orbit. The proton has a positive charge and the neutron has a neutral charge. So there you have it, fillies and gentle colts. The history of the atom. So, hopefully you're just as happy as I am to hear me stop talking. So thank you, have a good day, and how'd you get into my house?